Okay, this is the number 4 final review for first semester Algebra 2. The vertex form is one of the ways of graphing the quadratic equation we're going to look at today, and we're also going to look at the intercept form of graphing quadratic equations. At this point, we've done standard forms. So there are 3 different ways to graph a quadratic equation, and today you're going to look at 2 of those 3. The form for vertex form is y equals a times, a being the leading coefficient, in parentheses, x minus h squared plus k. And I want you to keep in mind that the pattern is going to be minus h plus k, because if it follows that pattern, then you just write the integer value down. But if it doesn't follow that pattern, then you have to use the opposite of that number. And we'll get into that as we go into this problem right now. So here's our first problem. Y equals negative, and I rewrote it down here as negative 1 in case you need that, times x minus 1 in parentheses squared minus 3. Well, our h is going to be right underneath the 1, and our k is going to be right underneath the 3. Our pattern is minus h, minus 1. Okay, so that works. So that one is just going to be, our h value is going to be 1. So h is going to equal 1. We already know that a, let's put the a in right now, is negative 1. That means our parabola will open down. So our h is 1, so it's minus h, so that followed the pattern, minus 1, plus k. Well, this doesn't follow the pattern. It's not plus 3, it's minus 3. So instead of 3 for k, it's going to be negative 3. All right, now with that said, this becomes a very simple job because the axis of symmetry is just x equals. Remember, it's always going to be x equals. Let's use a different color here. X lines cross the x-axis, so x equals, and then we've got h value, which is 1. So x equals 1. We're going to put a vertical line, because it's going to cross the x-axis at 1. And we're going to label it x equals 1. Okay, so the axis of symmetry, step 1 is done. Now we also know that for the vertex, the h value is going to just come over, which happens to be 1. So for your vertex, you're going to put in 1 for your x-coordinate, and you need to find your y-coordinate, which is your k value. So then we look at the k value. Oh, here's the k value right here, negative 3. And so it's 1, negative 3. So 1, negative 3 is our vertex. Okay, so we have 1 of the 5 points. This is very similar. You plug into a table of values. However, the difference is going to lie in that the values that you come up with. You're no longer plugging it into a standard form answer to get y. You're plugging it into y equals either negative times x minus 1 squared minus 3, or you can change that negative to a negative 1, which is what I'm going to do. If we look at our graph right here, if we look at the left, we can definitely choose 0. We probably then would have to choose a negative 1. So if you're more comfortable choosing 2 and 3, that would also work. I'm going to go ahead and choose 0 just because I don't think it'll be that difficult. So we'll put 0 in. I don't have much space here, so I'll have to go side to side. So it's going to be y equals negative 1. And again, you can just put the negative if you wish. 0 minus 1, because x value is 0, so that's going to be placed in here. We're just substituting squared. Minus 3. So then we have y equaling 0 minus 1 is negative 1, so it's negative 1 times negative 1 squared minus 3. Then we are going to do negative 1 squared. So negative 1 squared is 1 times negative 1 is negative 1, so negative 1. And then it's minus 3, but I'm going to go plus a negative 3. Using the additive inverse, subtraction changes to addition, positive 3 changes to negative 3. It's opposite. Negative 1 and negative 3 is negative 4. So 0, negative 4 is going to be our ordered pair on the left. What I would say to you is you always want to have that number sense about how this opens. And we looked at the leading coefficient. It's negative 1. It's going to open down. A is a negative, so it opens down. Again, that's a number sense idea that you want to have in mind. I prefer to do steps 3 and 4 simultaneously. We reflect for another point. We're 1 to the left of the axis of symmetry, so I'm going to go 1 to the right of the axis of symmetry, which is going to be 2, negative 4. I now have 3 of the 5 points that I need. Remember, this is not a V shape, it is a U shape, so make sure you do that. I'm now going to choose -1. I could come over here and choose 2, but it's probably in a better if you just stay on the same side of the axis of symmetry. So I went to the left, so I'm going to go to the left again and choose -1. But again, if you chose not 2, excuse me, you could probably choose 3. We've already have 2. So you could choose 3, and that would be okay, but I'm going to just go ahead and do -1. So -1, it's going to be y equals -1 times -1 minus 1 squared. And actually, I don't have much space here, so I'm going to actually do 2 of these steps at one time. Instead of doing -1, because I'm going to have different signs, I'm going to go plus a -1 squared, and then I'm going to go plus a -3, just because I don't have a lot of space here. So I'm just using the additive inverse right away. So -1 and -1 is -2, so we have y equals -1 times -2 squared plus a -3. I'm going to do some of this mentally just because I don't have that much space. -2 squared is +4 times -1 is -4 plus -3 is -7. So y equals -7. Now if you need to show those steps, you go ahead and do that. So it's -1, -7. The previous ordered pair was 0, -4. Okay, so -1, -7. -1, -7. And that's 1, 2 from the axis of symmetry. I'm going to go 1, 2 to the right side of the axis of symmetry, which will be 3, -7. And we're going to connect those points. Not such a good job there with this should have been a little bit more rounded this way, but oh well. Anyway, you get the idea. Even though it doesn't quite look properly 2 congruent parts, but it is actually, because the axis of symmetry, x equals 1, is dividing this parabola, which opens down into 2 congruent parts. All right, our reflections, which was step 4, we did simultaneously, and they yielded the ordered pair 2, -4, and 3, -7. And again, if you'd have preferred to choose 2 and 3, you would have come up with those ordered pairs, and then you would have reflected to get 0, -4, and -1, -7. It doesn't really matter. There's some variety here. Now I'm going to ask you to try a couple of these problems. Again, you should use graph paper. Please don't hand draw these. You can download graph paper off of the internet, but you can also use that green graph paper that you were given, which will yield a much nicer product. If you can't do either of those things, then please come and see me and I'll get you some graph paper. Before I move on to those other problems, I did want to point out one quick thing. The maximum value, anytime you have a parabola that opens down, you're going to have a maximum value. This is just vocabulary you should have some familiarity with. Is going to be the highest point of this parabola, and so the maximum value is going to be -3. Just something for you to know, that if you see something like that, you understand it's just the highest point of the parabola. Whereas if you have a parabola that opens up, then it's going to be a minimum value. Okay, here are your 2 problems. Number 1 is y equals 2 times, in parentheses, x plus 1 squared plus 4. I've set up kind of the steps that you need to use, including writing down what a, h, and k are. And the second problem, number 2, is y equals 1/2 times, in parentheses, x minus 3 squared minus 5. Again, I've asked you to write a, h, and k down just to keep yourself focused and understanding what values might be important for you. And then I want to remind you, in red at the top is the actual vertex form, which is y equals a, being the leading coefficient, times x minus h squared plus k. Go ahead and show any work that you need. The steps kind of spell it out for you, and then graph it, and then turn the recording back on to see how you did. Okay, on number 1, we have y equals 2 times x plus 1 squared plus 4. We know that our h value is -1 because it's supposed to be minus h, so we do the opposite of 1, which is -1. It is plus k plus 4, so it just becomes 4. So the axis of symmetry is x equals -1. We have a vertical line drawn at -1. The vertex is hk, so it's -1, 4. We have plotted a point in -1, 4. We know a is 2, so it's going to open up Okay, that's just a number sense situation. We know it's going to open up as it does. We also know with an a of 2 it's going to be narrower than what a parent function would normally be. We see that we can pick 0, so we go ahead and do that. 0, when plugged in, gives us the ordered pair 0, 6, and when reflected 1 to the left of the axis of symmetry, because 0, 6 is 1 to the right of the axis of symmetry, we get negative 2, 6. Picking 1, we do go off the graph, and not by much though, so it's okay. We get 1, 12, and 1, 12 is 2 from the axis of symmetry on the right, so 2 from the axis of symmetry on the left is negative 3, 12. Okay, so we have our 5 points, and they are all labeled, as well as our equation for the axis of symmetry. On number 2, y equals 1/2 times x minus 3 squared plus or minus 5. The pattern is minus h, so minus 3 follows the pattern, so it's 3. Plus k, it does not follow the pattern because it's minus 5, so k is going to be negative 5, the opposite of 5. So the axis of symmetry is x equals h, x equals 3, because the h value is 3. We have drawn a vertical line at 3 because that equation crosses the x-axis at 3. The vertex will be hk, h being the same value, or the h value being your x-coordinate value, your 3, the k being your y-coordinate value, which is negative 5, plotting that, 3, negative 5, labeling it. We also know, going back to the AH and K values, that A is 1/2, it's positive, so the parabola will open up, as you can see. We also know at 1/2, since it is less than 1, it's going to be a wider parabola than a parent function would be. You can see how wide it is. So we now have to find 4 more points. So we're going to use 0 because 0 is to the left. It may be that we can't use it because it's a ways, but we'll see. We plug in 0, we end up with 0, negative 3/2. Some of you would not like that, so you might have a little struggle with that, but you'll end up with 0, negative 3/2, which is 0, negative 1/2. We reflect that. We're 3 to the left of the axis of symmetry. We need to go 3 to the right, so it's 6, negative 3/2. We need another 2 points. We're going to choose 1 because 1 is also pretty simple, and it's to the left of the axis of symmetry. We end up with 1, negative 3, which that one came out nice. There was no fractional amount. We reflected. It's 2 to the left of the axis of symmetry, so we go 2 to the right, and we end up with 5, negative 3. Now we have 5 points, and we have a parabola that correctly opens up. Now, because we have limited time left on the recording, I'm going to just do I'm not going to be able to do intercept form on this particular final review. We'll do it on the next one, number 5. What I want you to do is just a brief review of inequalities and graphing inequalities. Okay, so we're going to do that on the next page. The final part of your number 4 final review will be just solving and graphing simple and compound inequalities. So you have x minus 3 is greater than 2x plus 4. Collect the variables on one side, so you're going to subtract x from both sides to keep the x value positive. Negative 3 is greater than x plus 4. Subtract 4 from both sides. And so you end up with negative 7 being greater than x. But many students prefer to graph this as x is less than negative 7. Open point above negative 7, and I labeled it down here. And then your ray goes to the left. For number 2, this is an and compound inequality. And you'll need to isolate the variable in the middle. So you add 5 to all 3 of the terms, of the parts, and you end up with negative 3 and 5 is 2. You end up with just 2x left in the middle, and then 7 and 5 is 12. Then you divide each part by 2, so 2 divided by 2 is 1. It's less than or equal to 2x divided by 2, which is x, which is less than or equal to 12 divided by 2, which is 6. Close point over 1, close point over 6. You know that it's going to be a line segment, and you can always check that because 3 is under the line segment. 3 is greater than 1, and 3 is less than 6. Due to the limited amount of time, I'm not going to be able to go through letter C with you. Here are your problems for 3, 4, and 5. Just remember to reverse the inequality symbol if you multiply or divide by a negative. When you turn this back on, you will be able to see the answers for 3, 4, and 5. So here are the answers to 3, 4, and 5 for you. Let me get as much of C done before we run out of time. Letter C was 9 is less than negative 3x. You divide both sides by negative 3. You reverse your inequality symbols, so it's negative 3 is greater than x. Over here you subtract 2x from both sides. You end up with 5 is less